So our first topic is a really important one, and it's going to be a foundation for pretty much all the calculations that you are going to do across this course. So it's really important that you get your head around this one. There's some stuff that you are just going to have to memorise, but once you got it, it's going to make life so much easier for you. So our topic is quantities and units, which are really, really important things. Because if you don't use units or quantities, then you get statements that look like this. So it took me 6 to get to college today. Now, just reading that, you know it sounds stupid. Because the question is, 6 what? I mean, was it 6 minutes, 6 hours, 6 seconds? I don't know. Are you even talking in time? Or you may be saying it took you 6 buses to get to college today. So without the unit, I don't know really what you're talking about, say time or means of travel, and I also don't know how big the thing you're talking about is. So it's really important that we use these units and also think about the size of them as well. So just to give you an idea of where we're aiming with this, whenever I do these presentations, you'll see down the left hand side there's something that says success criteria. So those are the things that I hope you walk away feeling like you understand by the end of the video. And if you don't, then you need to make sure that you ask me when you see me. So the things that I'm looking for you to know by the end of this are we need to be able to make some estimates of physical quantities. So common ones they ask are what's the mass of a man? What's the area of a foot? What's the distance between the Earth and the Sun? Things like this. So you need to have some idea of these very fundamental values. Now, they don't expect you to memorise them or know them exactly, just have an idea of the scale. Second thing is we need to be able to use SI units, and this is the thing that's going to come up over and over and over again. SI units, so I'll make sure you know what they are. We need to know the difference between base units and derived units, and we need to be able to get from one to the other. So the next thing we need to be able to do is check that our units are homogeneous. So that means that they are the same. So basically that one side of an equation gives you units that match the units on the other side of the equation. It's a way of checking that what you've done is actually correct. Because if your units don't match on either side of your equal sign, then you can't do what you're trying to do. And there's something wrong with your physics. And the next one is possibly one of the most important ones. And this is that you need to know and use prefixes for powers of 10. Now you already know some of these, but there are more that you will need to learn. So let's start by having a look at base quantities. Now base quantities are the quantities that all other units we will use in physics are derived from. So these are the important ones. You can't break these down any further, basically. So we've got them for mass, length, time, electric current, temperature, amount of substance, and the last one is luminous intensity. But we are not going to meet luminous intensity at all during the course, but I've put it on there for the sake of completion because this gives you all the base quantities. So the ones I most want to pull out for you to make sure that you're paying attention to are kilograms. So mass is measured in kilograms, not grams. All the others, I know we don't have anything like kilograms or there's no kilometres, it's metres, it's seconds, not minutes, but for mass it has to be kilograms, so do try and remember that one. And the other one that won't affect you too much this year, but it will for the second year, is that temperature, we work in Kelvin, not degrees Celsius. You probably have come across Kelvin in your chemistry courses, but we'll cover this again next year, don't worry. Just start it percolating in your brain and hopefully you'll remember by next year. And don't worry about moles, because again, we're going to meet those next year and we'll go over them then. Okay, so those are your base quantities. So like I said, any other unit that you have come across that is SI, or that we will use, can be made up of these units. So the best way to do it is to give you some examples. So these are derived units, all that we've got down here. So let's pick one that we might know. So let's have a look at speed. So speed, I hope you all know, is measured in meters per second. Now that's made up of 2 base units. It's made up of the base unit for length and the base unit for time. So it kind of says it in itself. It is meters divided by seconds, so meters per second. Acceleration likewise is pretty straightforward, meters per second squared. Again, that's just showing you the base units. But sometimes we decide, well, I don't want to write all that out because there's quite a lot there, so we give the unit a different name. So one you might have come across before is the Newton. So newtons are measured in kilogram meters per second squared. So the derived unit is the Newton, and the base units that it is made up of are kilograms, meters, seconds to the minus 2. So if you were asked to express newtons in its base units, they would be asking you to show that you know that it's kilograms, meters, seconds to the minus 2. Now the way we would know that is we would go and look for the equation in your data book that tells you how to calculate newtons, which is force. And the equation for force, the simplest one, is F equals ma. So mass times acceleration. Well, mass is kilograms and acceleration is meters seconds to the minus 2. So I don't need to go any further because there I've got all base units now. We'll practice this, don't worry. You have two options. You can either just memorize this list I've given you here, or you can learn to figure it out and pick it out from using the equations. Now, we're going to practice doing it the equation route because that's the best way. So that's the basis of how we would do the checking that it's homogeneous as well. Because, like I said, I can turn them down to their base units. So I can go F equals ma. Well, F is newtons, and I know that newtons are kilograms, meters, seconds to the minus 2. Then that equals ma, which gives me meters, seconds to the minus 2. Oh, it's the same on both sides. Sorted. I'll give you some examples when we're in class. I just want you to start thinking about it and see if you can visualize it in your head. Now, the next bit, I really want you to try really hard to get away from writing down lots of zeros. Because zeros are horrible and time consuming, and we are lazy physicists. We don't want to write all those zeros down. So why would I write 1 kilometre in meters? Because that's 1,000 meters. Look how much extra writing I had to do to get that on there. So it's much better if I'd just done it in kilometers, right? Now, I could have written it in scientific notation, right? So 1 times 10 to the 3 meters. That means exactly the same thing. And sometimes that is really useful because I might be doing something that's really huge, and I might want to use this notation because in physics we often look at really big things or really small things. So if I've got the size of an atom, I've got 0.00000000026 meters. See, all those zeros. That's a lot to write. When I could just write it as that, 0.26 times 10 to the minus 9 meters. Save myself a whole lot of energy. Now you might know I haven't quite done that in scientific form. And there's a reason for that. Because there is an even easier way to write it. Like I had kilometers as 1 times 10 to the 3, well, 10 to the minus 9 has got its own little letter. It's an n. So 0.26 nanometers is exactly the same as 0.26 times 10 to the minus 9 meters. And how much easier is that to write? So, what we're going to do is we're going to learn prefixes that we can replace them with. This is called engineering form. It is very useful. Now here's the list of all the prefixes I expect you to learn. Make sure you get the symbols and the numbers. Now you should hopefully note that apart from the exception that is centi, which you already know, it's times 10 to the minus 2, all the others go up by 3. And apart from the exception, because there's always an exception, of the k for kilo, if it's a bigger number, so a times 10 to a positive number, it's capital letter. And if it is a negative power of 10, so that means it's going to get smaller, then it is a lowercase letter. Now, little task for you. When I next see you, I would love for someone to be able to tell me what the symbol for micro is called. You should be able to see it there. It sort of looks like a slightly funky U, but it is not a funky U, it is a letter. If you can tell me how to say it when I see you next, I will be very impressed. So that's it for this video. I will try and keep them all a little bit snappier. I promise to get better. And I will see you all in class. Make sure if you have any questions that you ask them when you see me. And I promise we'll practice this a lot more. You should have some questions on haiku to have a look at as well to try and get this into your head. Okay, and I will see you in class then.